Rate of collisions per unit area. So what is this? So here in this particular topic, so as the increased temperature, so what will happen to number of collisions made by the molecule with the walls of container per second? So sir, why you are bringing suddenly this? This is something very, very, very important parameter. So let this be the walls of container. Area of cross section, L square. Okay, the molecule, let's assume that it is moving with a speed VRMS. It will rebound. I think there's a possibility, if the speed of molecule is more than VRMS, then its X component may be equal to VRMS. Will I agree? If a molecule is moving with a speed with a speed more than VRMS, then its X component of velocity can be equal to VRMS. So all the collisions are elastic. So therefore, what is the change in momentum? First, what is the change in momentum? Delta P 2m into VRMS here. Then we define the force delta F is equal to change in momentum by delta T. So this is 2m VRMS by delta T. What is delta T? Time interval between two successive collision. Shall I take reciprocal of that? What is delta T? Time interval between two successive collisions. Reciprocal of that, what it will give? Rate of collision or frequency of collision. Okay, agree this. So this particular thing, I'll call it as F dash. F for degree of freedom, F dash, frequency of collision. How many collisions per second? That is, so therefore this F dash is what I'm interested. Okay, before this, let me derive delta T. So what is delta T now? 2m VRMS by delta F. So now rate of collision is needed. So this should be 1 by delta T. So this will become delta of. So now let me go for rate of collision per unit area. Rate of collision per unit area. This is what Fn, let me write it. So this will be F dash by L square. Area, no? Okay, let me substitute here. Fn equal to F dash by A. Delta F by A, 1 by 2 VMS. What is the force per unit area? If you want to write delta A, it's left to you. So this will become pressure. Okay, let's write from ideal gas equation. So what is the pressure you can write? nR T by V. Mass of molecule. Mass of molecule we know. Mass of molecule should be m naught by Avogadro number. What is VRMS speed? 3 RT by m naught. Let me readjust all the things. NNA, this will be 2V m naught by RT by 3 m naught. And just check calculation all. One more very important concept. This is called like rate of collisions per unit area. So what is use of this? Okay, let's do one thing. I will fill up in a container. I'll fill up in a container helium and oxygen. Oxygen is a diatomic, will agree? Oxygen, helium is a monatomic, oxygen is a diatomic. Both are having same number of moles. So 10 moles of what's a 5 moles of helium, 5 moles of oxygen are filled in a vessel of volume V at temperature T. Okay, now I'm asking you which particular molecules will have more collisions, more rate of collision per unit area. Will both the molecules will have same rate of collision per unit area? Okay, let's come for this. Number of moles are same, 5 moles each. Volume, what is the volume of helium? That should be the volume of oxygen also. Am I right? Okay, this one. So therefore, Avogadro number same, our temperature is same, but molecular mass of oxygen is more than that of this one. So therefore, if I go for ratio of rate of collision for oxygen to that of helium, what you can write it as? This will be molecular mass of helium to molecular mass of oxygen. Anybody molecular mass of helium? Anybody answer?
4.
4, no, it should be. And then molecular mass of oxygen.
16.
So 1 by 4, 1 by 2. So therefore, what you can write it as? Which will have more number of collisions per second per unit area. The oxygen molecules will collide more with walls than the helium. Such a thing, Solpen, we can answer only by such parameters. What do we think? Okay, both the molecules are, since number of moles are same, the number is same. No, the number of collisions per second per unit area of oxygen will be more than that of helium. That's what this particular formula is telling. Okay, okay. This yeah, of oxygen. Yeah. So I agree this one. So these are the some inside what will happen to which molecules will collide more with the wall. We are able to answer. You try to imagine the science, modern science, so beautiful, no? How nicely they are going to that microscopic level. How all this will come? Huh? Not doing by meditation, eating good food, hmm, taking nutritious food, good facilities, observation, interested observation. Anybody is interested and you can make observation as 32, nitrogen 28, no? Okay, okay, molecular mass 32, sorry. 1 by root 8. Anyway, like nitrogen will be 28, no? Oxygen 32, yeah. Diatomic gas. Okay, I agree this one. So this about the inside, what will happen to the container there, we are able to go to that level. So whenever you get a mixture of gases, no? So here inside the gas, what about the total energy of the gas? As we are able to tell. What about RMS speed? Which will have more RMS speed? RMS speed of oxygen to RMS speed of helium. 3 RT by M naught. Again, it's same thing. Depends on molecular mass only. 1 by 8, no, it is 1 by 8 times. Okay, okay, it should be less. Huh? Yeah. Shall we go for the same similar condition? Okay, okay, I adjusted. Symbol I adjusted. RMS speed of which oxygen or helium, which will be more? I think we can keep on describe all this one. So which molecule will having more RMS speed? Helium will have more RMS speed than the oxygen. That's what the equation is telling. At a given instant, oxygen molecule will have more speed than helium, but RMS speed of oxygen should be less than helium. Will I agree? Because as I said, different molecules will have different speed and their speed will be continuously changing. It can happen, but RMS speed of oxygen should be less than that of helium. Okay, this is about the rate of collisions per unit area. We take help of this one. This is, I think it depends also number of moles for a given temperature. So you can see the number of moles, molecular mass, temperature. Volume of container will be same for mixture of gases, no? So T and V will be same. So you have to take ratio of N1 by this one. Okay, let's come forward. Okay, now I think we are in total